All right, hello everyone. So today we're going to be doing the Unit 4 review. Now in the Unit 4, as just kind of an overview of what is included in this unit, we saw topics from everything from perimeter to circumference, which are pretty much the same words in that we're looking for the distance around the outside. So if you take any shape, even as weird as the shape can be, that was actually kind of a weird shape there at the end. But any shape that you take, what we're really looking for when we say perimeter is adding up all the sides. So taking, this side plus that side, 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 plus that side. We're looking for the distance around the outside of that shape. If we have a circle, well, we don't have a bunch of flat lines that we can add up, but we are still finding the distance around that shape. But because there aren't flat sides, that's why we have a different word called circumference. So those two words kind of mean the same idea, distance around the outside. It's just circumferences specifically for circles. Then we have area, in which case area, as a reminder, is a two-dimensional idea. The idea that we are looking at this space inside of a shape, no matter what that shape might be. We focused on the shapes rectangles, squares, triangles, and circles, in which case we had formulas to find the areas of all of those. Then we got into definitions of diameter and radius, which again is looking at a circle. A reminder that diameter is a longer word, in which case diameter refers to going through the center of the circle, but going from one side to the other. So that's going to be diameter. Versus radius is a shorter word because it's a shorter line. It's only half of the circle going from the center to the outside. So a reminder of those words. And then last but not least, we did have volume, which again is a three-dimensional concept and looking at the volume of rectangular prisms, cones, cylinders, and then spheres. We also actually have triangular prisms, which we will look at later here. So in the first page, we just kind of went through all the definitions actually in that beginning, but let's get into some actual examples. So first off, we look at radius versus diameter. As a brief review, radius is the shorter word, which means it's the shorter measurement. So if I'm looking at going from radius to diameter, we're actually looking to find the longer measurement. Anytime we go radius to diameter, we are multiplying it by 2, which means our diameter is going to be 4 inches long. Okay, make sure that you do acknowledge that the unit involved here is inches, might change depending on the problem, but anytime you're going to radius to diameter, your number should be getting bigger. If you're looking at number 3 and we're going diameter to radius, again, diameter is the longer word and we're moving to the shorter word, so our number should actually be getting smaller, which means we divide it by 2. So if we have 4 feet, that would convert to 2, again, divided by 2, becomes 2 feet. Now here's where this problem, number 3, but the second problem that we're looking at gets very interesting. They actually give us the units. So please take note of the fact that it says inches, okay? You do need to be prepared for switching these units at any time. So in problem number 1, we had inches and we stuck with inches. But in this problem, they're making that clear clarification that they don't want it in feet, they want it in inches. So it is instinctual to just write 2 because that's the answer we got, 4 divided by 2. But actually 2 is not our answer for this problem. For this problem, we'd be looking at saying, well, yes, it's going to be 2 feet. But what is 2 feet in inches? Well, there's 12 inches in each foot. So that gives us a total of 24 inches. So please be prepared to switch the units when needed. Again, in number 7, you see it going yards to inches. Be prepared for that transition. Or in number 2, it says inches to feet. Be prepared for that transition. In the next section, we get into the idea of perimeter and circumference. And as we mentioned at the very beginning, these are 2 of the exact same words. It just one is specific to circles. So when we're looking at perimeter, we're looking at any given shape. So for example, this shape, in which case we're saying, let's add up all the sides. So if I started with any side, I'd be taking this one's 20. So I would have 20 plus, let's say the next side, 40, plus the next side, 10. And then we run into this issue with y. Let's just skip y here for just a hot second. We will come back to it, we do need it. But let's keep going around our shape and get to 30. and then we're going to add the 10 that's on the top. Then we have 20. We run into one more issue with this x, and then we're back to where we started with that 20. So the issue with this problem, and makes it a little bit different than the traditional perimeter problem, normally you just add up all the sides and you'd be done. But in this case, we're actually missing two sides. We're missing the y and we're missing the x. So could we go through and add up all these numbers? Absolutely. And actually, let me figure out what those will be. So we would have 60 and 40 and 30. So that gives us 130 is all the sides that were given to us. But again, we're still missing the y and the x. So this is where this problem is a little bit more difficult than our standard problem. But I want you to take notice of something. If I were to figure out the distance from here to here, we would call that y. From here to here, we would call that x. But then from here to here, we would call that 10. And is it not true that from this side all the way over to this side is 40? Well, if this whole thing is 40, and we know that this middle section is 10, then we can at least figure out, we might not be able to figure out the exact value of x and y, but we do know that between x and y, and then this given 10 right here in the middle, x and y have to be 30. Because if I have 30 from the x and the y, not individually, it's not like this is 30 and this is 30, together these two things would be 30, plus our additional 10 would give us our total of 40. So maybe x is 20 and y is 10. Maybe x is 10 and y is 20. We don't really care what x and y are, but together they're going to be 30. So we can actually replace this value of the x plus y with a 30, giving us our total perimeter of this problem, 160. So this would be considered an advanced kind of perimeter problem, excuse me, because we are missing two of those values. We can scroll down and actually find a much easier perimeter problem. So this one here actually gives you all of the values you might need, in which case, in order to find our perimeter, we would just need to add them all together, being extra careful not to repeat any of the numbers, or I should say any of the sides. If any of the numbers are the same measurement, that's okay. But if I start at 35, go all the way around your shape, and when you're back to 35, don't repeat 35, okay? So to find perimeter, we're gonna add all of them up. Now, as far as the circumference problem goes, 11 and 14 would be circumference problems. A reminder, you will have the formula on the test, in which case circumference equals pi multiplied by diameter. Now, number 11 is a nice one because they actually do give us diameter. From one side to the other, they tell us that it's 22 inches. But 14 does not give us diameter. So we're left with this question of, well, what is diameter? I need it for this formula. Well, they do give us radius, which is 3 inches. And if you think back to what we did at the beginning of this worksheet, transitioning from radius to diameter, excuse me, we should be able to figure out radius. Or sorry, we should be able to figure out diameter. If my radius is 3, that means my diameter must be 6 inches. And now that I have diameter, all I have to do is come over here to our formula, plug in diameter. I do and would prefer you to actually use the pi button on your calculator. So let's say that I take my pi button and I multiply it by 6. That should give us 18.8, and I'm going to round this to a 5 as my value. Make sure you include inches because we are looking at having units for all of these. And going back to our actual first example, I realized I did not put units. So we're at decimeters. I should include decimeters as my units. Perimeter and circumference are all one-dimensional, so you don't need to worry about squaring those units. It's just inches, period. And that would be our answer. Okay. Going on to the next page, we have some word problems here. I just want to help you set up problem 16 because this one tends to give people a little bit of problems. When reading this, it says you have a rectangular field. It's beneficial to kind of draw a picture here. And the rectangular field is 255 meters wide, but it doesn't really tell us our length. So we're missing length at this point. Again, it's tempting to think length times width, but it is talking about perimeter. So think about what perimeter really means. Perimeter means adding up all of the sides. Well, I know that these two sides are the same because it's a rectangle, and I know that these would both be L. So perimeter says, let's add up all the sides. So we're going to take 255 plus L plus 255 plus L, and that should equal, and they actually give us our perimeter of 1,400. Looking at this problem, combining like terms, I should be able to add these two numbers together and get myself a 510. L plus L would actually give me 2L equals 1,400. Solving this then as an algebraic problem would look something like this. We would subtract the 510 over, and we would have, let's see, 1,400 minus 510 gives me 890. Now 890 is the missing value. That's what we need in order to get the perimeter they told us. But if you remember, they're asking us for length, and we have two lengths of equal value. So we need to find a number that if I have two of them would give me 890. So let's just take 890 and divide it by 2, giving me a length of 445. Again, look at that units, and we're talking about meters here. Okay. You don't necessarily need to solve it in an algebraic way, but it does make a lot more sense when you think about we're just adding up all the sides and it equals 1,400. So you can actually set up a little bit of an algebraic problem there that we can then solve. Moving on to the next unit, we're talking about area in this problem. I want to remind you guys that we do, for the most part, have formulas for all of our areas. So if you come over to our formula sheet, you'll notice that we have the area of a rectangle, we have area of a triangle, we have area of a circle, and that's pretty much all of our shapes. Again, squares are just rectangles. So going back to our paper here, if we have circles, again, the area of a circle is pi times radius squared, and you could just get that off your formula sheet. This one's unique, and just a reminder, it says diameter is 22. They do not give us radius, so you have to figure out radius on your own. Diameter to radius means that my radius is actually going to be 11 inches. Okay, so be careful with that. Watch for that. They will switch up, or not units, but they'll switch up measurements for you. So they might give you diameter, but you need radius. Be prepared to make that transition. Number 20, again, this is a triangle, so make sure that you're using your triangle formula. 1/2 base times height. In this case, the base, they actually put it at the top, and that's okay, is 4. And the height, they don't tell you what it is, but it has that line, which means this is also 4. So be prepared for that. Watch out for triangles. 19 is an interesting one. We actually looked at this one in class. This is one where you actually might want to cut this shape off. So let's say that we cut the triangle off and we got rid of it. And let me completely black it out here. And let's say that I pasted that triangle down here. Now let me ask you, what does that shape look like? And all of a sudden, it should start looking like a square, in which case it is just a square. So we would be doing length times width, in which case our length is 23, our width is 46, and you'll have your answer. So you need to worry about the idea that we don't really recognize this shape. If you cut that triangle off on the top, completely cut it off, get rid of it, place it on the bottom, all of a sudden you just have a rectangle. So the rest of these area ones, like I said, as long as you're comfortable with the formulas, that's all you're going to be doing. And so we would be doing length times width for this one. We would be doing the pi times radius squared for this one, length times width for this one. Onward to the next page, we're actually just going to look 2 on the last page here. Number 24, I'm going to help you guys get set up because, again, this is one that gives people some problems. It says a circle has a circumference of 12 pi. So let me actually start out by just reminding you of the circumference formula. The circumference formula says pi times diameter. What they're telling us is that the circumference is 12 pi. So if circumference equals 12 pi, on the other side we have pi times diameter. They're asking us specifically, what is our diameter? Now you could solve this algebraically, or let's just look at this very closely. It says that we have 12 pi. So what number times pi, would give us 12 pi? Well, the pi is already accounted for. So what number times pi, what number must be our diameter? 12 must be our diameter. So this one doesn't require any solving when they give it to you like this. Had they given it to us as a decimal, and I just kind of want to warn you guys of this, if they had given it to us as a decimal, and let me actually figure out what 12 pi is as a decimal. So 12 pi would be, and this is just kind of an off-topic thing, but I'm going to get it to you anyways. Let's say that they gave you 37.7, because that's what 12 pi is. How would you figure out diameter now rather than logically thinking it through? Well, we need to get diameter by itself, and we have pi. So it's pi times diameter. How do I get rid of pi? You would just divide it over. In which case you would want to find 37 divided by pi, which should give you approximately 12 as your diameter. And now you have your answer. So if they give you the decimal version, you are going to need to divide both sides by pi. And then in the last section, we have volume here. Again, reminding you guys in the volume formula that we have volumes for all of these. So we have volume of a rectangular prism or solid. The cube is the same idea, so you can just kind of ignore that. It's still length times width times height. We have the volume of a cylinder, the volume of a cone, and the volume of a sphere. So you want to be familiar with using each of those. The only one that tends to give people some problems here is the triangular one, but you really have nothing to be afraid of with triangles. If you think of it, think back to the area formula for a triangle. The area for a rectangle is length times width. The area for a triangle is the same exact formula, we just chop it in half. Well, when it comes to volume, the same is true. The volume formula for a square is length times width times height. For a triangle, it's going to be the same idea. We're just going to chop it in half. So you still want to do length times width times height, but then just chop it in half. So they're the same principle here. And just because we don't have an actual formula for a triangular prism doesn't mean we can't do it. So we have, let's call this our length, let's call this our height, and let's call this our width. So all I would have to do is 7 times 10 times 5. Once I have that number, multiply it by 1/2 because it's a triangle. Had it been just a rectangular shape like 25, doing your 14 times 4 times 10 would be enough because it's a rectangle, so length times width times height. But because 26 is a triangle, we do just have to add in that factor that we only want half of it. Okay. The rest of them, as long as you follow the formulas, you should be good. So this is going to be a cylinder. Sorry, that was a bad D. Over here, you have your sphere. So follow your sphere formula. And then you have your cone. 30 is another sphere problem. It actually comes right out here and says it's a sphere, but it's chopped in half. That's what you're seeing here. So it doesn't go upward like a normal sphere would. It's chopped in half. Still follow your sphere formula. So let me pull that up for you down here. Here's our sphere formula. Still follow that, but then when you get your answer, just like the triangle, chop it in half. Okay. So that takes you through kind of all of them. For the most part, I acknowledge the fact that I didn't really walk you through examples of the formulas. If you need specific examples of these formulas, please just go back into your notes and it should show you, or at least walk you through specific ones of volume, cone, spheres, and so forth and so on. But otherwise, just be familiar with the formulas. You will get the formulas on the test. They're not necessarily something you have to memorize. But you do at least want to be familiar with the idea of plugging in radius and things like that. And that is about it for Unit 4.